So now we have to start with a new topic, that is hybridization and shapes of molecules. We have three types of hybridization for carbon compounds. The first is sp3, the second is sp2, and the third is sp. We have to understand that the carbon atom in alkanes have sp3 hybridization. The carbon atom in alkenes have sp2 hybridization, and the carbon atom in alkynes have sp hybridization. One by one we will be discussing in detail how the hybridization and the shape of the molecule can be determined. Just as discussed right now that sp3 hybridization is found in alkanes, so the simplest example we can take for alkanes is methane. Now, how do we find the hybridization? For finding out the hybridization of the central atom in any molecule, firstly what we need to do is we need to write the ground state electronic configuration. Carbon has atomic number of 6, that means we have 1s2, 2s2, 2p2. For finding out the hybridization, we only consider the outermost shell. If we make this in the boxes orbitals, so this is 2s2 and we have p orbital in which we have 2 electrons. This is 2s orbital and this is 2p orbital. We can see that in the ground state we have 2 unpaired electrons, that is this and this. The total number of unpaired electrons shows that how many bonds it can form, how many bonds the carbon can form. We can see that we have 2 unpaired electrons. That means by this we know that carbon can form 2 bonds. But in the formula we can see that carbon is forming 4 bonds. And to make 4 bonds we require 4 unpaired electrons. To make that possible, what we actually do is that we excite the electron from 2s to 2p. So for that we will write the electronic configuration for the excited state. That becomes 2s1 because one of the electron has been excited to 2p, and this becomes 2p3. So this orbital is 2p and this is 2s. When there is excitation of the electrons, then these orbitals will not remain as 2s or 2p. Okay? They actually become sp3 orbitals. Why they become sp3? Because hybridization means mixing of the orbitals. So we have 3p orbitals, means we have 3 orbitals of p and we have 1 orbital of s, which forms 4 equivalent sp3 orbitals. 4 equivalent sp3 orbitals, which will be overlapped by the s orbital of hydrogen. And since we know the shape of the sp3 orbital as tetrahedral, so this is the shape of the sp3 orbital in which we have unpaired electrons, which will be overlapped by 1s orbital of the hydrogen, which is spherical in shape, containing unpaired electron. So this is the shape of methane, or we can make it like this. And this shape is known as regular tetrahedron. We see that carbon has a sp3 orbital, sp3 hybrid orbital, which is overlapping with the s orbital of hydrogen. And how they are overlapping? They are overlapping by head-on overlapping, forming a sigma bond. So these are nothing but sigma bonds. And the bond angle between the carbon and the hydrogen is 109 degrees 28 minutes. So we can say that the shape of the methane is tetrahedral. The second example of alkane that we take is of ethane, that is C2H6, which can also be written as CH3CH3. If there is a confusion, you can also write it as H3C and CH3, because in this formula we basically show the bonding between carbon and not hydrogen and carbon. Okay, so first of all, again we will write the electronic configuration of carbon. And again we see we have 2 unpaired electrons, so we excite the 2s electron to 2p, and when we excite this 2 electron to 2p, then the orbitals does not remain as s and p. In fact, they become sp3. That means we have 4 equivalent sp3 hybrid orbitals which will be involved in the bonding. Now how will it will be involved in the bonding? This we have written for one carbon, but how many carbons are involved? We have 2 carbons involved. And just now we have done the shape of the sp3 orbital. So we will make the shape of the sp3 orbital that we have 4 equivalent sp3 orbital. This is one carbon. That means this carbon. We will make the same for the second carbon. Now how many hydrogens I have? We have 6 hydrogens, 3 here and 3 here, in which there will be head-on overlapping. But first we will write the electronic configuration of hydrogen, that is 1s1, which has a spherical shape. And how many hydrogens I have? I have 6 hydrogens that will be overlapped with the sp3 orbitals of the carbon. So we have this like overlapping. So we can easily see that I have 1 electron of s orbital and I have 1 electrons or sp3 orbitals. So we can directly make like this. And one overlapping is happening between sp3 overlapping with the sp3 orbital. And here we have sp3 overlapping with the s orbital of hydrogen. So what kind of bonds are being formed? This is sigma bond. This is also sigma bond. This is also sigma bonds. We can make it like this. And all the single bonds are sp3 orbital. So all the single bonds are sigma bonds. If we talk about the bond angle between hydrogen and carbon, this is 109.5 degrees. This bond length is 154 picometer. This bond, hydrogen bond length is 109 picometer. So this is how we make the shape of the ethane. Now, if we take an example of alkenes, which have the carbon and sp2 hybridization, the simplest example of alkene that we will be taking is C2H4, which is nothing but ethene. The common name for ethene is ethylene, which you must remember, right? So again, what we see that we have 2 carbons and 4 hydrogen. We know that we have sp2 hybridization in the alkene. So firstly, we will write the electronic configuration of carbon. We see that again, we have 2 unpaired electrons, so we will excite the electrons. Now, since the sp2 hybridization is involved, the one orbital of s with the 2 orbitals of p, means 1 box of s and 2 boxes of p, will be hybridized. So this becomes sp2. So in the hybridization, 1 orbital of s and 2 orbitals of p, 2 orbitals of p means 2 boxes of p, will be involved and form the 3 equivalent sp2 hybridized orbitals. And this orbital, which is not involved in the hybridization, is unhybridized p orbital. And what is the shape of the unhybridized p orbital? Is normally dumbbell shape. And what is the shape of the sp2 orbital? Is planar, trigonal planar. And how many carbons are involved? We have 2 carbons involved. So firstly, we will try to make the sp2 orbitals of the 1 कार्बन. एक कार्बन के 3 sp2 हाइब्रिड ऑर्बिटल्स बनाएंगे और उसके बाद 1 अनहाइब्रिडाइज्ड p ऑर्बिटल बनाएंगे. So this is 1 sp2 orbital, this is another sp2 orbital, and this is the third sp2 orbital. We'll make it like this. So these 3 are sp2 orbitals, and we have to make unhybridized p orbital here. So this is a unhybridized dumbbell shaped and equally dumbbell shaped unhybridized p orbital, and this is for 1 carbon. In the same way, we will make it for another carbon because we are having 2 carbons here. So we'll make 3 sp2 hybrid orbitals. So this is 1 sp3, एक sp2 बना, not sp3 but sp2. This is another sp2 and this is third sp2. Unhybridized p orbital of the second carbon will be equally dumbbell shaped, right? How many hydrogens we have? We have 4 hydrogens, and hydrogen, we know that, has 1 electron, that means 1s1, and this has a spherical shape, and each of the orbital is containing 1 electron in sp2. Now we see that we have unpaired electrons in sp2 as well as unhybridized p orbital, so we'll make 1 electron here. Remember that you have 4 electrons here, so 3 I have made, this is the 4th one for 1 carbon. In the same way, I will be making 4 unpaired electrons here, so this is 1 1 3 and here I have 4. Do not make it here, otherwise ये 5 हो जाएंगे इलेक्ट्रॉन्स. हमें 5 इलेक्ट्रॉन्स नहीं बनाने, हमारे पास तो 4 इलेक्ट्रॉन्स है, तो हमें एक ही इलेक्ट्रॉन बनाना है. See, I have made 4 electrons of one carbon by green color, and I have made 4 unpaired electrons for the another carbon, and I have 4 hydrogens which will be overlapped by sp2 orbital. So these are the 4 overlapping. This type of overlapping is sp2 and s orbital, sp2 of carbon and s orbital of hydrogen. This type of overlapping is sp2 of carbon with sp2 of carbon, right? But there is one point that is left, is that we are just showing the sigma bonding here, but there is some kind of a pi bonding also involved, and the pi bonding will be shown by the lateral overlapping between the unhybrid orbitals of carbon. If I talk about the bonds, so this is my sigma bond here, this is my sigma bond here, and this is my pi bond. Now we will take the examples of alkyne. The simplest example of alkyne is C2H2, that is acetylene by common name, and ethyne by iupactane. Carbon electronic configuration is 1s2, 2s2, 2p2. This is the ground state, that is we have excited state here. Now we know that in alkyne we have sp hybridization. That means in the hybridization, one orbital of s and one orbital of p will be involved. So this becomes sp and this becomes sp. These two are unhybridized p orbital which will be involved in pi bonding, and this will be involved in sigma bonding. अब हम यहाँ पे डायरेक्टली हाइड्रोजन का भी लिख लेते हैं. तो हाइड्रोजन has 1s1 electronic configuration. The shape will be s orbital, so the shape will be spherical here. Now we have to remember that the shape of the sp orbital is linear, so we will be making two sp orbitals. This is one sp and this is another sp, और ये एक कार्बन का है. ऐसे ही दूसरे कार्बन का बनाएंगे हम sp orbital. तो this is one sp orbital and this is another sp orbital. तो ये कार्बन नंबर 1 का है और ये कार्बन नंबर 2 का है. दोनों के sp orbitals बन गए हैं. Now we have to make the unhybridized orbital also. So I will be making unhybridized orbital like this. One unhybridized p orbital and this is another unhybridized p orbital. Here I will be making one unhybridization p orbital and this is another unhybridized p orbital. तो in short चार orbitals बन गई है दोनों कार्बन की. ठीक है. And how many hydrogens are involved? I have 2 hydrogen for complete molecule. So I have 1 hydrogen here and I have 1 hydrogen here. Now I will be filling in the electrons very carefully. See how the electrons are filled. यहाँ पे हाइड्रोजन है और यहीं पे कार्बन का है. यहाँ पे हाइड्रोजन है और यहीं पे कार्बन का है. ठीक है. यहाँ पे दोनों कार्बन के हैं. तो this is your sigma bond, this is your sigma bond, this is your sigma bond. ठीक है. Now कार्बन के कितने इलेक्ट्रॉन्स हो गए? एक इलेक्ट्रॉन यहाँ हो गया, एक इलेक्ट्रॉन यहाँ हो गया. दो इलेक्ट्रॉन्स हो गए. फर्स्ट कार्बन के 2 इलेक्ट्रॉन्स हो गए, सेकंड कार्बन के भी 2 इलेक्ट्रॉन्स हो. मतलब अभी 2 इलेक्ट्रॉन्स पड़े हुए हैं. थर्ड एंड फोर्थ इलेक्ट्रॉन्स आर हियर एंड थर्ड एंड फोर्थ इलेक्ट्रॉन्स आर हियर. तो दोनों कार्बन के 4 इलेक्ट्रॉन्स हो चुके हैं. ठीक है. नाउ हाउ द ओवरलैपिंग विल टेक प्लेस. सो दिस विल ओवरलैप विद दिस. सी वेरी केयरफुली. एंड दिस will overlap with this laterally. So this is forming pi bond here and pi bond here. So how the overlapping is taking place? So we can form it like this. I have a single bond here, single bond here and single bond here. That means this is your sigma bond and I have 2 pi bonds. So I have these 2 pi bonds. Okay? The white color are of pi bond and the shape of the molecule is linear. Now, as we have already done sp3, sp2 and sp hybridization in the carbon molecules, to summarize all, we can write it as sp3 hybridization. What are the participating orbitals? Means hybrid orbitals के अंदर कौन सी orbital participate कर रही है. तो we can see that I have s orbital here. That means I have 1 orbital of s and I have 3p orbitals. 3p का मतलब ये नहीं है कि 3p है. 3p का मतलब है कि that is 3 boxes of p orbitals. Number of equivalent orbitals, कितने hybrid orbitals बन रहे हैं sp3 से. Now for calculating this, अगर आपको याद हो पहले भी chemical bonding में कर रखा है, s कितने हैं और p कितने हैं, तो आपको इन नंबर्स को प्लस करना होता है. तो sp3 orbitals कितने बनेंगे, 4 बनेंगे, that is 4 equivalent orbitals. कितने अनहाइब्रिडाइज ऑर्बिटल है, 0. कोई भी ऐसा नहीं था जो पाई बॉन्डिंग में इन्वॉल्व थे, सारे के सारे सिग्मा बॉन्डिंग में इन्वॉल्व थे. sp3 का क्या स्ट्रक्चर था, दैट वाज टेट्राहेड्रल. बॉन्ड एंगल वाज 109 डिग्रीज 28 मिनट्स. एंड सारे के सारे एल्केन्स के अंदर किस तरीके की हाइब्रिडाइजेशन होगी, मींस जहां जहां सिंगल बॉन्ड होंगे वहां वहां क्या क्या हाइब्रिडाइजेशन होगी, दैट इज sp3. तो द एग्जांपल इज इथेन, मीथेन, और इन जनरल यू कैन से दैट alkane. The next is that sp2. अब sp2 के अंदर कौन सी participating orbitals है, तो we can see that I have one s orbital, means एक one box of s and कितने boxes of p, that means two boxes or two orbitals of p subshell. जब भी number of equivalent निकालना होता है तो हमें इन numbers को plus करना होता है, that means 1 plus 2 that is total 3, लेकिन total तो 4 होती है, तो एक और आपके पास unhybridized orbital बचा हुआ है. तो this is one unhybridized orbital जो कि p orbital था, जो कि पाई बॉन्डिंग में इन्वॉल्व. तो इससे आपकी बनती है पाई बॉन्डिंग. तो इसके अंदर कितने सिग्मा बॉन्ड्स होंगे, 3 सिग्मा बॉन्ड्स होंगे, एंड आई हैव 1 pi bonding. Structure will be trigonal planar and the bond angle will be triangle की फॉर्म में है, तो of course the bond angle will be 120 and the example is ethene. जहां पे भी डबल बॉन्ड इन्वॉल्व होगा वहां पे आपका किस तरीके का हाइब्रिडाइजेशन होगा, sp2, और शेप क्या होगी, ट्राइगोनल प्लेनर. और यहाँ पे कौन सा अनहाइब्रिडाइज ऑर्बिटल था ये भी आपको याद रखना है, दैट इज pz. बाय कन्वेंशन वी टेक इट एज pz, मतलब px, पी वाई और पी जेड में से पी जेड वाला इज अनहाइब्रिडाइज. थर्ड कम्स द sp. हाउ मेनी बॉक्सेस ऑफ s, 1 s ऑर्बिटल एंड 1 p ऑर्बिटल, लेकिन टोटल तो 4 होते हैं ना. तो यहाँ पे अगर मेरे को इक्विवेलेंट ऑर्बिटल्स निकालने हैं तो इन नंबर्स को प्लस करना है, दैट इज 2, एंड टोटल कितने होंगे, अनहाइब्रिडाइज भी 2 होंगे, मतलब 2 पाई बॉन्डिंग बनेंगे. यहाँ पर अनहाइब्रिडाइज ऑर्बिटल हमेशा पाई बॉन्डिंग बनाएगा, और कौन सा p ऑर्बिटल होगा, पी वाई एंड पी Z. The shape will be linear, course, and जब भी linear shape होती है तो bond angle will be 180 degrees, and the example is of alkyne. The simplest example is ethyne or propyne. This is a summary of the type of hybridization of carbon atoms.